Hey guys, welcome to my channel, Coding Ninja, and today we will be solving the daily LeetCode problem 1498, number of subsequences that satisfy the given sum condition. Now, let's just read the problem first. You are given an array of integer nums and an integer target. Return the number of non-empty subsequences of nums such that the sum of minimum and the maximum element on it is less than or equal to the target. Since the answer may be too large, return the modulo in this number, 10 to the power 9 plus 7. Okay, so looks like a straight enough question. Now, let's just think about it for a second and list down our assumptions. So, since it is not given, we have to assume that the arrays are sorted in a random order, or in a random order. Although it might look like it, but we cannot assume that every time we will get the array, which will be in the increasing order only. In an interview, you ask the interviewer this question, like if there is an order of any sort or anything like that. But here, since we are doing it on LeetCode, we don't really have a choice, and we'll have to assume that they are in an unsorted order. And so it also appears that numbers can repeat themselves, so that is another thing we have to take care of. So thinking about the brute force approach, we can obviously apply the brute force approach to this solution question and come up with the solution. Like we'll just keep adding these numbers. So first it will just be 3 and 3, so that can satisfy. So as it shows, like 3 and 3 will satisfy, 3 and 5 will satisfy, 3, 5, 6 satisfies because the maximum is 6 and minimum is 3, and similarly 3 and 6 will satisfy. So basically you can do this iteration over and over again for all the numbers, but since we are trying to find a subsequence, it will contain a huge amount, so an array of size n will have the number of sets to be 2 to the power of n. So this will obviously be greater than the time complexity we are allowed in this scenario, and so we should not, and we cannot take this approach because it will most likely time out. Now, looking at the minimum and maximum element, my mind automatically goes to some sort of an order. So if we have some sort of an order in the array, we can then use the two-pointer approach to start from the left and the right, and we can go from there. So that is what my mind instinctively goes to. And thinking about the solution, let me just start a comment over here. So let's just say we have an array in the ascending order. We have sorted the array, and taking this example only, let's just think about that. Now we can have two-pointer approach where we start the left as 0 and right would start as n minus 1, which in this scenario would be 4 minus 1, which would be 3. Now what we can do is, if the sum of the nums left and nums right, in this scenario 3 plus 7, is greater than a target 9, which it is. 10 is greater than 9, so we decrease the right side by 1, because since we are already outside the boundary, so increasing from the left won't do us any good. Instead, we have to reduce it from the right side. When we reduce from the right side, we will be instinctively getting a smaller sum, since the smaller or equal to sum, since we have sorted it in an ascending order array. So in this scenario, we'll go to 3 and 6. So the right would become 2, and the nums of right would be 6. So now it satisfies our condition. So it will be 3 and 6. So 3, 5, 6 is the array. And now what we'll have is, we have 2 to the power of left minus right, because that is now how many subsequences we can form out of this. All right. So let's just code it up. So first things first, I would like to get all the basic variables down. So int n is equal to nums dot. You might hear some keyboard chatter, so I'll try to keep the typing separate and my speaking separate. So I'll do it step by step. So we'll need 4 to 5 integers at least. So we'll need one for the number for the length of the array, since I don't want to keep going for length minus 1 every time I have to access it. Then we'll need a left pointer, then we'll need a right pointer, which in this scenario will simply be just two numbers will be pointing to the positions left and right in the array. And then we'll need one answer variable which will store the answer, and one will need the modulus variable in which we can store the modulo number 10 to the power 9 plus 7, so we don't have to keep writing it over and over again. Okay, let me get that. All right, now we have our basics down. And now I also need to sort the array. So as I mentioned, we will need this arrays to be sorted in some sort of an order. Okay, now we also have our array sorted. Now we'll need a loop so we can iterate over the loop and get the subsequences. Now coming to one thing. So for here it will be beneficial for us to use a while loop, since we don't exactly know if we are going to be increasing the left or will be decreasing the right pointer. So, and for loop is a loop which is better used when we have an exact number. Okay, I want to go from 1 to 10, and that's only. But in this scenario, we don't have that. So I'll be using a while loop, and the condition would be left is less than equal to right, because we want to keep iterating it and finding each and every subarray. Okay. Now since we have that, now as I mentioned, we can add the sum, have the sum of the left and the right, the nums left and right, and check that with the target. So here in this scenario, as I mentioned, we'll have to reduce the right side because our sum is greater than target, and we don't really have any sort of we cannot use this subarray. I mean, we cannot use the subsequence. Now in the else scenario, basically our condition is satisfying that left plus right is less than or equal to the target. Now we need to find the number of subsequences. So here the number of the subsequences would be 2 to the power of right minus left, because that is how many subsequences we'll have. Now it seems like we'll have to use this a lot of times. So I was thinking we could just have this sorted, have the values already in a different kind of an array, and we can have the modulo applied over there as well. So to reduce our cumbersome task over and over again. So I'll just do that right now. So this array power of 2 will basically store the powers of 2 for my use in the else statement later. So the zeroth position would obviously be 1. So as I mentioned, we will be doing the mod at each and every step so as to not have any sort of overflow issues. Now, since we have this power of 2 array setup, now we can go ahead and write the other else part where we need to add the subsequences to the answer. So here, as I mentioned, the answer would be 2 to the power of left minus right. Okay, let me just have a look at this and everything like, okay, this name is incorrect. Okay, it looks like everything is right. Let me hit run. Okay, cannot find symbol. Okay, there's a spelling thing over here. Okay, we seem to be running fine. Let's hit submit. And it is accepted. Now, coming to the time and the space complexity. So here I'll just add a comment. So time complexity and space complexity. So looking at the different steps, so sorting would obviously take n log n time. The internals, like the arrays dot sort, it takes n log n time. So like we cannot, there is no other way around it. This function to create the power takes power of n time, and this will also take power of n time, since the left starts at 0, right starts at n minus 1, and once we have a crossover, we are done. So we'll only be doing it n times. So it seems like this is also power of n, big O of n. So the most time consuming statement we have is the sorting statement, which gives us a time complexity of big O of n log n. And okay. And looking at the space complexity, we just have a space complexity over here, where we are, these variables are all on taking constant space. The sorting algorithm takes constant space. Just this power of 2 array will take big O of n space, and we don't have anything else. So yeah, it will be a time complexity of big O of n. Yeah. So this seems like the final result. Okay, I'll post this answer in a GitHub repo where you can access this later. And let me know if you have any questions in the comment section. I'll be happy to answer those. And keep coding. Have fun.